percentiles and quartiles are basically measures of positions. They're a little bit different from the z-score, but still useful in comparing values within the same data sets. Let's take a look at an example of what percentiles and quartiles are. Let's imagine that there are 100 teams, 100 basketball teams in the NBA. The season has come to an end, and they have ranked those 100 teams by their winnings. Let's, for example, say that the Los Angeles Clippers is ranked at the 70th percentile. Then that would mean that they are better than 69 of those teams that are ranked below them. Or in other words, they're better than 69 teams. If the Los Angeles Lakers are ranked at quartile 1, each quartile is 25%. So if they're ranked at quartile 1, it would mean that they are better than 24 teams. I'm going to go in a bit more details with the definitions of some of these terms so that you have something to refer to. So, first of all, the median separates the data into two equal parts. That's why it's the number in the middle, right? And in any data set, that's going to be 3 quartile. We call it Q1, Q2, Q3, which is the first 25% of the data, the first 50% of the data, and the first 75% of the data. But in order for us to find these Q1, Q2, Q3, make sure that you sort your data from lowest to highest first. So once the data has been sorted from lowest to highest, then we can identify the Q1 value, the Q2 value, and the Q3 value. The Q1 value, what it does is think of it as separating the bottom 25% from the top 75%. So it's kind of like that number that separates the lower 25 from the top 25. Q2 is also known as the median, and what that does, it separates the bottom 50 from the top 50%. Okay. So if your data, let's say if your test score is the median score, then that means that half of the students in class score below your score, but you're also your score is also lower than half of the students in class. The quartile 3 is at the 75% mark from the lowest. So we say that this is the score that separates bottom 75% from top 25%. Let's say if out of all the test scores, your test score happens to be the value of Q3, then that means that you score better than 75% of the students in your class. So these is just one of the numbers of the data, and I'll show you how to find these a little bit later. Now, generally, there are 99 percentiles, and they're denoted by P1, P2, P3, all the way up to P99. Which, if this would be the case, if the data were to be partitioned into 100 groups. That's why I kind of started with the example of 100 basketball teams. And that means that each group would be about 1% of the data value. Now, the percentile, the way how to find percentile can be kind of confusing, but I'm hoping that this may simplify the process a little bit. Let's say if I want to find the percentile of value of X, so perhaps the Clippers has performed throughout the season, they rank they're at a specific spot in the standing. In order for me to find their percentiles, what I have to do is I have to count the number of teams that rank below them divided by the total number of teams in the league, and then times that by 100. Then that allows me to find the percentile. Okay. Round to the nearest whole number. Round the percentile to the nearest whole number. So as we continue to develop our understanding of percentiles, here are some of the symbols that we're going to use. So make sure you know these symbols well. The symbol N is one that we hopefully you know already, because we always use that to represent the total number of values in a data set. Here are the three new notations. One of them is the letter K, which stands for the percentiles being used. L, which stands for the location that give the position of a value, and P sub K stands for the kth percentile. Oftentimes you might see like P sub 25, which would mean that the 25th percentile. Alright, so this can seem kind of confusing, but hopefully the next few examples can help clarify these. Say that the sample age of some of the actresses in Hollywood are summarized in this data below. I want to know what percent, find the percentile corresponding to an age of 27. In other words, if an actress is 27 years old, how is she in comparison to the actresses who are below her? So to find the percentile that represents an age of 27, we are going to start by first finding the total number of sample actresses. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 actresses in each row. And we have 1, 2, 3, 4, 5, 6, 7. 7 times 70, so 70, 71, 72, 73, 74, 75, 76. So we look at a sample of 76 actresses. Now I'm going to have to find the number of values less than X. So I have to now count how many actresses are less than 27 years old. So since X is 27, because that's the focus point, that's what we want to focus on. So now we need to find how many actresses are less than 27, and let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 actresses that are less than 27. So the percentile of X, okay, so percentile of X is equal to, we take 12 because there's 12 people less than, that are less than 27 in age. Divide that by the total number, which is 76, and we multiply that by 100. So 12 out of 76, that gives us 0.157 multiplied by 100, and that's just shifting the decimal. So we're looking at 15.78%, and we always round to the nearest whole number. So I would round this to 16%. So 16%. What does that mean? It means that 16% of the actresses are below 27. Okay. Find the percentile corresponding to an age of 38. So first there's 76 actresses. The focus age is 38. Now, how many of them are below 38? Well, you got 10, 20, 30, 40, okay, 50, 51. So 51 divided by 76 times 100. So 51 divided by 76 times 100, that gives you 67%. So 67%. One way to understand the percentiles is to say that there are 67% of the actresses are below the age of 38. So you're at the 67 percentile. That means that you're a little bit over that median percent. In the next part, I will talk about the particular percentile location, which is the score. So watch the next video for this.